Mr. Parbat?
Hey.
How are you?
I'm doing well. How are you doing?
I'm studying.
I can see that.
Yeah, I made a study sheet last couple of weeks.
Great.
Yeah.
I'm glad about that.
I went ahead, by the way. I hope you don't mind. Like,
no, it's fine.
I know I made a study sheet better than yours. I mean, I don't want to be insulting, but you did a crummy job. I mean, you forgot to mention the sulfur oxiding bacteria
okay, yeah, well, I will touch on that later. Are you ready for your test?
I
want the usual name, OSIS, date, period. Right, well, I see your palette.
I still have time to study. Stop.
Right, well, your palette tool here isn't ready yet. We'll just have to wait for a minute. Well, if it isn't your parallel tool here, I guess you're ready for your test, right? Alright, so listen up. I just want the standard name, OSIS, date, this usual stuff, right? Don't forget the period.
Gotcha. Got a pencil? It's too dark. Who's that? I'm sorry.
Hello, boys. Guys ready for your results?
Always ready.
So you know this. Right. Let's start with the good one. Good job, Edmund. That's really good. I'm really proud of you.
What? But Mr. Parbat, no, it's impossible. I could not. I did it for 100.
Well, you kind of
Well,
just...
what is this? I studied for weeks.
I know.
Weeks.
I know, but you messed up.
Mr. Parbat, I want you.
Right.
Got a 19, bro. Party at my house. It's an improvement, Mr. Parbat.
No,
Mr. Parbat, this is ridiculous.
No. Tool. That's your 6th test that you failed this year, and
7.
You're 7.
Yeah.
Wow. All right. Oh. You're gonna have to take a retake.
I demand a retake too.
You got a 99.
I deserve 100, Mr. Parbat.
What happens if we fail?
Well, if you fail, you're gonna have to retake the entire course, and you have a 99.5 average.
I demand 100.
I'll see you both next week for the retake.
Everyone, I need to come to your house to study.
Okay.
No, come to my house.
Alright.
See you later, man.
You nice, man?
Come in.
Sorry about that, gentlemen. Thank you, Joe. I'm sorry, your mom's not in and everything. I didn't know that. I had to. We have to do some. Can you computer?
Sure. So what are we learning today?
We're learning about Winogradsky column. We learned this a couple weeks ago, Joe. Weren't you in class?
Yeah.
It's about the Winogradsky column. Actually, I have a good way to teach you, and I know just how to do it. I practiced the other day. It was pretty good, actually. I think so. Yo, Ratul, let me teach you something that you didn't learn in school. It's about my boy Winogradsky.
Yo, man, shut up.
Damn.
I'm sorry. Are you serious, man? Wanna teach it to me a little simpler?
Come here. Alright, we'll be learning about Winogradsky today. Alright, so, do you know who started who made the Winogradsky column?
Miss Pride?
No. It was Sergius Winogradsky. He was the one who made the Winogradsky column.
Oh, really?
Yeah, he actually made it to show how the different microbials develop over time, and it's a column, but it's layered.
Yeah, we
It's
have one in
layered.
class.
Oh yeah, it's like a test tube. Yeah, it's a test tube, right? And what we do first is that we go to lake and we take up the soil and all the mud that's there, right?
Mhm.
And we fill up about a third of it, right?
Okay.
With in the test tube. And the rest we fill up with lake water, right?
Alright.
Also, we should inside the mud we should like throw in stuff like sulfate and like cellulose and all that stuff, right?
Mhm.
All that good stuff, right?
Yeah.
Alright, and when you put that there, cover it.
Do you remember something about layers?
Yeah. Cover it, put it inside the sunlight, right? Eventually, the bacteria inside each of them, right? They're gonna create layers, right?
Okay.
On top layers are the aerobic species, right? Those ones that use oxygen, because oxygen it takes a while to diffuse inside.
Okay.
So
that's in the top.
that's on the top. So the ones on top are gonna be the ones that use oxygen more, right?
Mhm.
The ones on the bottom are gonna be the anaerobic ones, right? Who don't use water oxygen as a respirator, right? Those bacteria will be filled. And the way the bacteria works is that it's the sheeted bacteria on top, right?
Yes.
From the sheeted bacteria, you'll see the cyanobacteria on the bottom. It'll take up a large portion. And then below that, right, it'll create a purple bacteria that doesn't require oxygen. Those are the anaerobic species, right? Below that, below the purple are S bacteria, right?
Yeah.
The S bacteria are the dominant species right at the bottom of in the bottom middle of the column. Alright? And then, I have a better idea. This can't work.
Alright, so let me teach you something about the Winogradsky column. It was invented by Sergei Winogradsky as a device for culturing large diversities of microorganisms. The Winogradsky column is a tube of pond water and pond mud mixed with a carbon source such as a newspaper and a sulfur source such as calcium sulfate. Incubating the column in sunlight for months will result in aerobic, oxygen-needing microorganisms and anaerobic, microorganisms that don't require oxygen gradients. And it'll also create a sulfate gradient. These three gradients promote the growth of different microorganisms such as Clostridium, Bacillobrio, Clobrium, Chromatium, Rhodomicrobium, Bigatio, as well as many other species such as cyanobacteria and algae. In addition to anaerobic and aerobic zones, there are areas that form in between them. The transition from aerobic to the oxidized zone represents a microzone for chemoautotrophs. Okay. In the reducing zone, anaerobic conditions dominate. Anaerobic photoautotrophs and chemoautotrophs are residents as well as sulfate reducers and ever-present fermenters. In reducing zone, anaerobic conditions dominate. Anaerobic photoautotrophs and chemoautotrophs are residents as well as sulfate reducers, methanogens, and ever-present fermenters. Though each column is unique, depending on its various soil compositions, over a sufficient amount of time, patterns will emerge within the column. The three major zones are as follows. The aerobic zone, as I mentioned before, the oxygen-needing microorganisms, in which O2 will diffuse in and out of the surface layer. The oxidized zone, consisting of nitrates, sulfates, and oxidized iron. The reducing zone, consisting of ammonium, sulfide, and reduced iron. Each of these zones hosts specific organisms. One such example is in the in the anaerobic zone, where the sulfur photosynthetic bacteria, chlorobium, exists. Examples of organisms that might be found in the aerobic zone include algae and cyanobacteria. The transition from aerobic to oxidized zone represents a microzone for the following organisms: chemoautotrophs, both nucleophils and sulfur oxidizers. And in the oxidized zone, heterotrophs dominate, including the denitrifier and sulfate reducers. In addition, fermenters may also be in the zone.
So do you understand the Wygotsky column now?
I think I do. I don't know.
I mean,
Yo, man, even I get this, man. You mad dumb, yo.
Scary, friend.
Crazy, man.
Where is he? What's he getting here? What's he getting here? Where is he? The bell rung 30 seconds ago. Where is he?
He's right there.
Mr. Parbat, do you have our tests?
Yes I do, guys. Cell phone.
Sorry.
What did I get?
Alright, well, here you go. I think you're gonna be happier this time around.
Yes! I got 100!
It's okay.
What'd you get?
79! I passed!
Yeah!